My parents kill me if I see. Kill.
Good.
My mom
Get this one up.
kills me when I have a scene. I don't have a scene in here right now.
Oh, you don't?
I will. That or me, but I have a scene in here. I am.
Oh, also make sure, some of you might not have turned in that review packet last time. That's gonna go down as 0 today when I stick it in there if you didn't.
Wait, what
Huh?
review
I
packet?
will-
Where did I guess just?
The review packet that we did.
Where do we turn it in? Oh, was it the one we got like mid-September?
Yeah,
I have a question.
yeah.
I have this one packet in here. For some reason I have it in my quiz section, but it says reading to learn, like the.
That was, I said you can put that in your notes section.
Wait, this
I
one?
don't know why I put it in here.
No, not the other one. I'm gonna collect that one here in a minute. The one that was a review for the test. Problem number 1.
You already collected that one.
The review packet, yeah, I have.
Okay, so you're talking about the one you just gave us after the test.
No, listen carefully. Listen. I know this is hard with all young ladies in here. Everybody focus on me. So I don't have to say this 6 times. This, I have not collected yet. All right? The review packet, I collected the day of the test. Okay? But some people did not turn in the review packet. And I'm giving them a second chance because maybe they just forgot to lay it on the brown table when we took the test. Does everybody remember when we laid them on the brown table?
Yes. You should.
So Ariel, do you have it?
Yeah,
Are you gonna turn it in?
I will eventually.
Eventually like today, otherwise it's going
Yeah.
down to 0.
Yeah, I'll get it in today. I got you.
Don't forget, because
I got
once I
you.
put in that 0, I'm not taking it away.
I
So
got
you're not collecting this at all.
I'm
I
gonna
have you.
You just said you're talking about the other thing, giving a second chance. You didn't say anything about this yet.
He says we're turning that in today.
I said that like 4
Yeah,
times.
yeah. I heard the first one actually.
Okay, I don't know.
No more questions. Listen now, I'm going to explain it all. If you don't get it, you're out of luck. The review packet, which most of you turned in, I had you turn it in the day of the test. You were supposed to lay it on the brown table up there. If you didn't turn it in, get it into me today, I'd still accept it. That's over with. The other 2 things that are due today, I will collect here in a few minutes. The first one is this paper. So that will be collected here in a few minutes. The second one is the test redo. Redo it on a separate sheet of paper, staple it to your test, and I'll collect that here in a few minutes. Everybody with me now?
Yeah.
Problem number 1 on page, what was it, page 462? Is that right, 460?
Yeah.
Oh, I'm on 467, no wonder. Problem number 1, identify the following transformations. Blue figure is the pre-image. Anybody remember what the pre-image, what that means?
Is the first one?
All right, the pre-image is what you're starting with, and then the image is what you end up with. So on number 1, what did they do there?
Rotated.
Rotation. Everybody agree with that? If I could spell. Number 2, dilation. What's a dilation do?
Either make it
Makes it
bigger or smaller.
Bigger or smaller. All right? Dilation's the only one that actually changes the shape. Okay? Before we go on, what's the other 2 transformations that you probably learned in the past? Translation and a reflection. Good. Number 3, what they do there? Reflection. Reflection. Number 4,
Translation.
translation. Sorry, I had to look at the picture twice. Number 5, dilation. Again, a dilation is different than the other 3 because a dilation actually changes the shape. On reflection, rotation, or translation, the shape stays exactly the same. It just moves to a new position. Number 6, reflection. Good. Number 7, Translation, everybody agree with that? Notice this is why I don't write in cursive normally, because it's right there where you read. Reflection. Reflection again. I hope these are all right, because I'm not even looking at my book. 10's translation. What's another name for a translation again? The generic or layman's term.
Okay.
A slide. Good. A slide.
Yeah, 11.
11's confusing.
Well, no, not really.
Confusing.
We just say
Isometry,
which
which
ones
ones
are.
All right, it says an isometry is a transformation in which, and that's one of the vocab words we're going to talk about today. And isometry is a transformation in which the resulting image is congruent to the pre-image. Which transformations are isometries? We just got done talking about that. What's the only one that changes the actual shape? Dilation. So which ones keep it the same? Translation, reflection, and rotation. Now, before we go on to all this stuff, a couple of things I want to say. You've done all these in the past, but do you think that what we do this time is going to be as easy as what you did in 5th or 6th grade?
No.
It's going to put a whole lot more into it. So even though you think, I know everything about there is to know about reflections, because I did really well on that when I was in Mrs. Smith's 5th grade math class, don't believe that, because it's going to be a lot different and a lot more complicated. Right? You're expected to know more now, not just the same thing. You're expected to know more. So don't think that just because you know all these, it is a little bit of review, translation, a little bit of review, but some of it will be real new. Okay? Do what?
The dilation shouldn't be that hard.
That's probably the hardest one.
Not that this matters or anything, but you spelled dilation wrong.
Yeah.
There's no A in the front part.
D-I-L-A-T-I-O.
Like,
I did that too, then I erased it.
D-I-L.
Yeah, I always do that.
Dilation. Dilation. That's pretty bad, isn't it?
I was thinking about.
Still better than this text, BS. She's like writing that. She's like BS, like saying
We're
it.
going, no,
BS.
No,
She's like BS.
All right. The next thing, the test review, or the test redo, sorry, and this worksheet. Before I collect them, any questions over this worksheet?
No. I think I have one, but I find it first. Did we turn in our test with the
You
questions?
staple to it.
Okay.
Okay, so I was like on the second page when it says quadrilateral.
Okay.
That confused me, like, cause like I know you can just label it with a point.
So where did you see a quadrilateral?
It's 25.
I know that. Which,
Oh, I use the JT GP.
that's what you write down.
Just that. Okay,
Yep.
that's what I wrote. Okay.
Other questions? Questions on the test? None? Right. What I want you to do, make sure your name's on this. Your name should already be on your test, so that shouldn't be a big deal. Make sure your name's on this. The test redo, the stapler is laying on the desk up there. Take them both, lay them on the blue chair. Both of them can be in one pile. I'll sort out the pile here in a few minutes. All right, go ahead and start copying this down today. Go ahead, I forgot to do that in the first class. Oh,
Because I need to like, I need to make sure I get my paper back on education this time. So I
I never lied.
make sure I get my work, make sure I do have it as a paper.
Start copying. What we're going to cover today, reflections. Don't forget to put your lines on there. I will come around, check your reflection at the end of this lesson. Today is the first, 10-1. Knowledge before the lesson, make sure you go ahead and fill that out, put your blanks on there, do all that. What we're going to cover, reflections. I know usually when you do transformations, that's what all of them are called together. Normally, translations is the first one that you cover. This book switches it around for whatever reason, doesn't matter. But know that as we do all these transformations, you will be confused, all right? It is a lot more difficult than Mrs. Jones back in 5th grade saying, all right, students, take this rectangle and flip it over the y-axis. It's going to be a lot harder than that.
Just so you know, the fifth grade teaches this a lot, so you got that down.
Not anymore.
Mrs. Smith, Mrs. Jones.
So be able to, what we're going to do, be able to draw reflections, reflected images. Be able to draw lines of symmetry. Anybody remember what a line of symmetry is?
Where you
Point
can
down
fold
the
it
middle.
perfectly
Now, does
and
it-
equals the same.
Exactly. It's got to have both those things, all right? And we're going to talk about that when we get to it here in a second. Points of symmetry. You might not have ever talked about points of symmetry. We're going to talk about that. Recognize this is a big one on like the OGT test or the whatever test they're going to end up making you guys take. This is a big one. Recognize how a shape has been reflected. A lot of what they want you to do now, instead of you being able to reflect the shape, is they want to give you the pre-image and the image and say what operation was done to this shape. The picture, I will use the picture to show some examples of different things.
Are we going to be learning about escalation?
Yeah, we'll do those too. Just real quickly, because when it comes to stuff like that and isometric drawings and all that,
Well, I was
I'm
wondering
horrible at it,
if
so.
I'm writing down definitions.
Yeah, well, we'll get to it. We're gonna learn that at some point, yeah. All right, a reflection. Another name for a reflection is just a flip. So either one of those that you use, I'll understand. The one that people get confused on the most is dealing with the image and the pre-image. And you guys already sort of showed me that you probably understand what that is. The pre-image is what you start with. The image is the new shape or what you end up with after you do the reflection or rotation or whatever it is that you happen to be doing. All right, line of symmetry. Somebody give me a definition that we could write for a line of symmetry.
A line has something to make it equal to each other.
Equal on both sides.
What's the, how are we gonna start it? A what?
A line
A line.
that-
That's a good start.
that
That's
divides
Okay, you gotta draw some.
a
Divides
object
and both
into
sides
two
congruent.
equal proportions.
All right,
Perfect.
makes the
And
two shapes congruent. That's good. Now you got to be careful because if I draw this right here, is that a line of symmetry? No, because these two are congruent to each other. They're the exact same, but what's wrong? What else do you have to be able to do when you're talking about a line of symmetry? Somebody said it earlier.
Make sure both sides
Well, they're both equal there. What do you got to be able to fold it, and they got to match up exactly the same. So let's say a line that splits a shape.
the line that can be drawn through a plane figure so that the
We didn't want the definition out of the book. That's why we're coming up with our own
That's a good
definition. A line that splits a shape into two congruent shapes. But we also need to put something else in there. What else has to be true? That
Equal up to each
sort of, that match up when you do what?
other. Folded.
When you fold it over, when folded. Alright, so line of symmetry, in the book's definition might be a little shorter than that, but we want to make sure that you understand it. A line that splits a shape into two congruent shapes, well, this line does that part, but if we fold it across that line, it wouldn't match up, so that's not a line of symmetry. How many lines of symmetry does that brown shape have?
None.
None. There's no line that we could draw in there anywhere that's going to make it fold up exactly the same. How many lines of symmetry does this blue arrow have? One. Where would it be?
That's the, like,
Horizontal.
Yes.
All right, so it goes horizontal across this way. That line right there would match up exactly, and the two sides are exactly the same. And I'll say this word wrong every time because I have no idea how to pronounce it, and I really don't care. I could look it up, I guess, but I'm not going to take the time. Isometry or isometry, however they say it. Isometry just tells you that the pre-image, what you started with, and what you end up with are exactly the same. We just talked about that. What's the only transformation? What's the only only transformation that isn't isometric? Dilation. Dilation. So if you wanted to write in there, reflections, rotations, and translations are all isometric, something like that to help you out. Just know that if you do a reflection with this blue shape, the new shape's exactly, it's got to be exactly the same. So if you come up with an arrow that looks like this, what do you know? You did something wrong, okay? You moved your points wrong or something went wrong. So the image should look exactly the same as the pre-image. Let's do this real quick. If I take a rectangle, piece of paper is a rectangle, right? I take a rectangle. Sarah Ray is going to draw a line of symmetry on there for me.
Oh, can I like hold it first and
No,
then?
don't do that.
Oh, but that's been perfect.
No, it doesn't have to be perfect.
No, that's gonna be really
I'm
bad.
going to make fun of you when it's not perfect. So she drew that. Everybody agree with that? Yeah, it's probably pretty close. If I folded it, do the two parts match up exactly the same? Do they look the same? Look congruent? Yeah. Ariel's going to draw another one on there for us. Can't copy Sarah Ray's. So don't be trying to be a cheater. All right, so she drew this. I'm going to fold it along hers. Everybody agree with that? Those two parts look the same? Did they match up? Okay, close enough, right? I'm not asking you to be exact. Kelsey's going to draw another one. Everybody see where Kelsey drew hers? Everybody agree with it? Yeah? All right, so let me fold it. Did it work? So you got to be careful. All right? Looks like a line of symmetry because Is this triangle over here exactly the same as that triangle over there? Yeah, right. But does it match up when we fold it? So that's why when you're doing lines of symmetry, it has to do both things.
But if you take an inch off it, like,
It'd be more than an inch, but yeah.
well,
If you made it into what shape? A square, then it would work. If you also made it into a rhombus, it would work. But with a rectangle, it doesn't. So you gotta be careful when you're looking at those. Looking at this shape. How many lines of symmetry do you think we have on it? 2, 4? Where would one be?
Straight through the middle,
Straight through the middle?
like up and down vertically.
So right here? If I could hit it correctly?
Yep.
That's a line of symmetry?
Horizontal.
Horizontal across this way?
One diagonal, well, one, both diagonals.
Yeah.
And then the other diagonal. And then maybe another diagonal in between. Okay, well, like, I guess you could do
You
in
could
all
do
the little
another
corners,
diagonal.
little creases,
You could, where at?
like,
Right.
in between the, you can't,
Like
yeah,
right-
no, down a
no,
little
no,
point, there,
right there, yeah.
Right there?
Yeah,
And where am I gonna take it
to
to?
the other side.
The other side, like how?
Like,
Like,
straight
this
across.
goes to,
Like that?
like,
Yeah,
Yeah.
and then do it with the
Now,
next one.
before we go any farther, be careful with that. Is that gonna match up?
I think so,
I
yeah.
don't think it is.
no.
No.
I'm saying it would. Yeah?
Yes, no? Let's vote. How many people think yes, that line right there would be a line of
Oh,
symmetry?
wait, no, it's not.
Nobody wants to, everybody's too chicken to vote yes?
But I did vote yes.
Yeah.
So
I
vote,
vote
raise
yes.
your hands.
I
Vote
vote
yes.
yeah.
I'll just say whatever.
1, 2, 3, 4, 5. Can't be in between. It's a yes or no question, Ariel. 5, yes or no, quick.
I guess I'm really
Yes, so we got 6. How many people think no, it's not? 1, 2, 3, so we're gonna say yes, it is, because democracy, right?
Hey, what's what we're learning about?
So- So what could we do to figure it out?
Fold it?
We could make it, alright?
Make it.
Now, probably, because do you think I could make that real quick if I just start
Yeah,
cutting and
you're
stuff?
perfect.
Nah, it doesn't, I appreciate that, Katie. That's why you got that test score,
Yeah.
because
Uh-huh.
you say stuff like that. But if we look at that, is it gonna fold and match up?
Yeah.
I think it is.
And then do it all the
And
other
you would
little.
just do it at every single one of them.
Yeah. Yeah.
Now, the other thing down here.
That's why I forgot one.
Did I forget one? Yeah, I did. The other thing down here, point of symmetry. What do you think the point of
The
symmetry is?
center.
That point right there, if I could have drew them all straight, that point where they all cross is called the point of symmetry. Okay? How many lines of symmetry did that shape have? A lot's not a good answer. If you write a lot on the test, I'd be happy with that because I'll have a good laugh and then I'll mark it wrong.
16.
16? 17?
Ooh, wait, no, I can't look at the
10.
account like that.
How could you do it? If you're doing this on the paper, how could you do it?
17.
Start somewhere and maybe mark them.
Say 8.
Count for me.
There's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
No, like.
That's wrong.
Yeah, that's what I was saying. Yes.
Why is it
okay,
wrong,
I get
Katie?
this, because like they're the same lines. It's one big line. You
That's
can't
what
have
I'm
two.
So when we counted all those, this line, when I counted it over here, isn't that the same line as over there?
Yeah, it's not like you count.
So how
there's
many
only
is there
eight.
actually? There's only 8,
Because it's not like you count
because you
by
want half of
arrows.
it. You don't want to count all the way around it. You want to count halfway around it, because otherwise you're counting the same lines twice. All right. Next 3 slides are going to look like this. It's rules. Write this down. This tells you reflection. You got your coordinates, how to find the new coordinates. This gives you the rule, different ways to come up with that rule. This is what you're reflecting over in the rule. So write those down. Again, the next 3 slides, basically all the same setup, because we're going to learn how to, these are the 2 you probably already know, over the x-axis, over the y-axis, then we're going to learn like 4 others that maybe you know, maybe you don't. These are the ones you probably went over in the past, reflecting over the x-axis. This gives you the rules. I'm not sure why I used A and B instead of X and Y. Does everybody understand that it means the same thing?
Yeah.
So if you wanted to change this and put X, Y, and it goes to X, negative Y, go right ahead if that makes more sense to you. I think I put it this way because that's the way the book wrote it, and then once I had it on my PowerPoint, I thought I should have switched that to X's and Y's instead of A's and B's. It made more sense to the students. So this is what you do. You start off with X, Y. If you're going over the x-axis, the coordinates basically stay the same, except the y-coordinate becomes the opposite of what it was. All right, and when we get to this other, when I show you a couple examples here in a minute, I'll show you the way that you used to do it, which was probably just by counting, and show you why that's all right sometimes, but a lot of the times it's easier if you use the rule. If you're going over the y-axis, remember your x-axis and your y-axis. This is your x, that's your y. Make sure you don't forget which axis is which. If you're going over the y-axis, instead of the y becoming the opposite of what it was, now the x-coordinate becomes the opposite of what it was. And again, with a lot of these, it's probably easier to just count. All right, on this, and you can write down whatever you want. You don't have to write any of this down. I'm going to just make up some triangle here. Oh crap. I don't like that triangle, but we're not going to use it because it's not going to work out. Erase that. Let's do this triangle. We'll call this point A, point B, point C. Help me out. What's the coordinates for point A?
2, 3.
Make sure we're reading right every time.
5, 4, 5.
5, 5.
Okay.
Everybody agree with that?
Yeah.
And C?
7, 3.
Now what the rule says to do is you take that 2, 3, and if we want to reflect it over, let's do the x-axis first. We want to reflect it over the x-axis. You take that 2, 3, and what did the rule say? Multiply which coordinate by -1?
Y coordinate by -1.
Multiply the y coordinate by -1. Let's make it green. So what would the new ordered pair be?
2, -3.
And for
-2, 3.
B, it was 5, 5, right?
Oh,
What's that going to be now?
-5. Or what?
5,
Negative
-5. And for C, it was 7, 3. What's the new one going to be?
7, -3.
7, -3.
Wait, I'm confused. So right after you find out
Oh.
the coordinates are, you change it immediately?
Well, what you're doing, you found the coordinates. Normally, and I'll show you this, normally, if you were doing this when you were back in 5th grade or 6th grade or wherever, what'd you do to figure out where A went to?
Went over and
You counted down, all right? Said, all right, A went up 3, so now it's going to go down 3. And when you labeled this, you no longer labeled it A, what'd you label it? Anybody remember that?
Negative
This was A, now it's not A anymore, now it's A
two.
prime.
Oh,
It's
yeah.
got A with that little, like, apostrophe above it. So this is A prime. B, you just counted, it was up 5, so if you're going over the x-axis, you go down 5. Is it all right to still do this one that way? Yeah, but when we get to a lot of the other ones, you've got to make sure you know how to do it using the rules. C went up 3, so now it's going to go down 3 instead of C, it's going to be C prime. Looking at that, is that the same coordinates? What was the coordinates that we said A should have been? 2, -3, is that 2, -3? Yeah, and it works out that way. Sometimes they'll just give you the coordinates, and they'll want you to reflect it across the x-axis. Do you have to draw it then? Could we just do the rule and just come up with the new coordinates and write down that as our answer? Yeah, so if you know the rule, sometimes it's going to make it a whole lot easier. What if we wanted to go across the y-axis? What happens?
Then you would multiply the x coordinate by -1.
So what's the new coordinate for A going to be?
-2, 3.
-2, 3, which is just going to be right here somewhere. Now when we label it, we're going to label it A prime,
A negative prime. A not prime.
A double prime. You put 2 of the little marks. All right, what if you had a 4th picture on here somewhere?
A triple prime.
A triple prime, so on and so on.
A
1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Wait, will we put 2 ones or?
It's just like 2 apostrophes. So it looks like this. Not like that. If this is our A, it's got an apostrophe, and it's got another apostrophe. It's sort of like a 1, except it's sort of slanted.
Look at 11 slants.
Right. And if we had a another shape that we were going to do, we put a 3rd one.
So you just keep adding dashes.
Right. And hopefully we don't go much past 3, because if you start going past 3,
I was gonna
Gets
say,
confusing.
I don't think they're
it doesn't work out very well. C was 1, what was it, 7 over, so it's going to go 1, 2, 3, 4, 5, 6, 7. C double prime, and our shape would look something like that. Should have made that one a different color so that we could see all 3 of them in different colors. What's this shape called again? That's true, it's a triangle. It's the pre-image. It's the pre-image. What's each of these other 2 shapes called?
Image.
Images. All right. A lot of times on like the OGT or whatever test, they'll want you to do something like a double reflection, where you take it to here, and then maybe you take that shape to somewhere else. All right? Don't let that confuse you. You just got to do it one part at a time. It's not any harder than doing 2 separate problems. So with the x and y axes, it's probably easier just to count, but sometimes it's going to be easier to use the rule. Going over the x-axis, you just multiply the y coordinate by a -1. Going over the y-axis, you multiply the x coordinate by -1. All right, write this down. 2 more rules. These are a little tougher. These are ones that you probably did not see in the past. Or maybe you did and teacher sort of went over them sort of quick, got annoyed because they're a little more difficult. As you write these down, anybody know what y equals x? What's that? What is that? From algebra, when you have y equals x, anybody remember what it was? Okay, it's in slope-intercept form, all right, and it's just a line. It's a linear equation. Y equals x is just a line, but it's a line where the b part is 0. So it's like y equals x plus 0. If I wrote y equals x plus 0, stuff that we're going to go over later on this year, what's the y-intercept in that line? Where does it cross the y-axis? 0. What's the slope? 1. So that means it goes up 1 over 1, up 1 over 1. Rise over run. And we're going to go over slope later on in the year. And that's what the Algebra 2 students are doing right now. I think the pre-calc students are doing it right now also. And they're all whining and crying, oh, no slope. Don't do that when you get over there. Mr. A comes back and says, why aren't you teaching these guys how to do slope?
I love slope.
Rise over run.
I remember that one.
All right, the first one, reflect over the origin. What's the origin?
The line, the
0,
0, 0. You might want to write that in so you don't forget. So you're reflecting it over the origin, over that, just that certain point. And then the second one is reflecting over this special line, y equals x. And I'm going to show you that line here in a second. If it helps you, maybe you could, I'll draw this, our x and y axes. The line y equals x, I'll draw it in there in a different color so maybe it make a little bit of sense to you. We'll do it in black. Y equals x, if we did a table of values for y equals x, when you did a table of values in algebra, what x's did you normally pick?
0, 1.
Usually probably pick 0, 1, 2, 3, something like that, right? Let's pick some negatives though so we get on the other side too. So what would you pick? Go farther. -2. Now, if we were plugging into this equation, y equals x. So if I plug in, for x, I plug in -2. What's y end up equaling? -2. What's it going to be for -1? -1. They're all the same, right? Because y equals x. That's all we're saying there. So one of the points is -2, -2. One of them's -1, -1, 0, 0, 1, 1, 2, 2. And it's a line that goes through here, something like this. So it's that line. So we're reflecting over that line, whatever shape we have. Maybe we have some smiley face over here. It's going to end up where? Over there somewhere. Reflected over that certain line. Now another one that they use a lot, y equals -x. What do you think changes on that? Instead of the line going this way, what's going to happen to it? Goes this way. And then whatever happens there. All right, I'm going to go back to this real quick, just because I forgot to do something. Another thing that's going to help you if you know the rules, because I know that these are ones that confuse a lot of people. What if I drew my shape? And I told you to reflect it over the x-axis.
Wouldn't the A stay in the same spot?
Would that stay in the same spot?
I feel like it would.
If you're going over the x-axis,
Oh, wait, no, never mind. It
it's
would
going to go
down, yeah.
down here somewhere, right? This one's going to jump above it, this one's going to jump above it, and your shape would look something like that. So when you do that, it might be easier to do the rule, because is that something that you could picture in your head when I first wrote it up there? Probably not. Okay? So if it's laying on one of the axes, you probably want to use this rule right here, where you multiply by a -1 either on the x coordinate or the y coordinate. All right, so if we're going over the origin, let's make this Q, R,
S.
let's use T. we have that shape. What was the rule for going over the origin? You have x, y, and it goes to what? Negative x, negative y. Is that right? What's the coordinates for q right here? Help me out so we can get through this.
3,
Close.
minus
3, negative 3. How about t?
Negative 3.
8, negative 3. How about r?
8. Oh wait.
6, negative
6,
1.
negative 1.
All right, this is one where it's going to help out a whole bunch if you come over here and do this rule. So we're going to go r was 6, negative 1. What's r prime going to be? If you times both of them by negative 1, negative 6, positive 1. Does everybody see that? Sydney, you see that? Q was 3, negative 3. Watch, because I guarantee that most of you are going to be confused when I graph this. 3, negative 3, what's it going to become?
Negative 3.
Negative 3, positive 3. That's Q prime. And then T was 8, negative 3.
Negative 8, positive 3.
Negative 8, positive 3. Now I'm going to graph these real quick. Do it in a different color. Let's not use that green anymore. That didn't work out very well. Purple. Negative 6. If I count wrong, please tell me. Purple's probably not a good one to use either since the lines are sort of purple. That's R prime. Negative 3, 3. That's Q prime. And negative 8, 3. That's T prime. And it looks something like this. Move that R out here, R prime. Would you have guessed that that's what it was going to look like? As a matter of fact, where most people get confused is like this T right here. It was, or maybe the R was on top, now where's it at? On bottom. That's when you're going over the origin, right? When you're going over the origin, what you're sort of doing, you're like reflecting it over the x-axis, then reflecting it over the y-axis, and that's what's going to happen to it.
Yellow.
Let's try to do this orange. So let's go with R double prime. This time, instead of going over the origin, if I can draw this line sort of straight in here, probably not. That's the line y equals x. That's what the line is going to look like, y equals x. If we flip it over top of that, if we reflect it over that, what the rules say for y equals x? What's it do? Goes to what? So it just turns them around? All right, so what was the coordinates for q? Let's do r, sorry, I already wrote it down.
6,
And what's it going to become? Negative 1, 6. How about q double prime? And how about t double prime? Let's graph that. Now, is this a lot easier? Doing the points first, then graphing it? And if you don't think it is, you're going to mess up. Because if I ask every one of you to come up here and draw where that's going to end up at, across that line or across the origin, you're probably going to mess it up. Okay? Negative 1, 6, negative 1, 6. Anybody have any idea that R was gonna end up way up there? -3, 3, and that is, what is that, Q double prime now? So that Q double prime ended up exact same place as Q prime from the other one. That's not something that's gonna happen all the time. -3, 8. -3, 3, 6, 8. That's T double prime. Is that the picture you had in your head? Probably not. Alright, so whenever you're doing across the origin or across a special line, you're gonna be a whole lot better off to use the rule, write down the ordered pairs, and then go from there to graph it. One more set of rules. If I'm going over, if I'm reflecting over x equals some number, like x equals 3. Anybody remember what special kind of line that is? Again, that's something else you learned in algebra. X equals 3, what's special about it? If I was to make a table of values, what's x going to be every time?
3.
What could y be? Could be anything. What kind of line is that going to make if you graph those? You go 3, 0, 3, 1, 3, 2, 3, 3. What kind of line is it going to end up making? Vertical line. You might want to write that down here. This is when you have a vertical line. When it's x equals some number, it's a vertical line. What do you think it is when it's y equals some number? It's a horizontal line. So when it's y equals some number, it's a horizontal line. Me and Mr. A were talking about this the other day. Is one of his tests he just gave in Algebra 2, he had him graph y equals 7 or something, and a whole bunch of them missed it.
Okay, the last one I wrote down was reflection, too, just was reflection.
They all say reflect. They're changing. They're changing what they reflect over and stuff.
Okay, no. Never mind. Just got that on the line.
I just realized that and I'm like, wait. Okay.
All right, so on these, when you're doing these, the best way to do it, just count. And I'm going to show you why here in a second. You're better off to just do what you learned in 5th grade or wherever it was and just count from the certain line. So you're just going to count to reflect it over this certain line. This only works if it's vertical or a horizontal line though. All right, if we take a shape, let's just do something real quick and easy. As a matter of fact, I don't even want to do a shape. Let's do a segment, just to make it even easier. Somebody be counting on that and find me those coordinates here in a second while I make up something. X equals, let's see, x equals -2, let's say. What's the coordinates for this one? 4, 3?
I think it's 8, 8.
8, 8? Does that seem right to everybody? Now, we want to reflect it across this line. What kind of line is that line? Vertical?
Yes.
Is everybody scared? Can't remember which one it is, so didn't want to guess. It's x equals -2. So what you do is you go to where x is -2, and you draw in a vertical line. That's the line that we're reflecting this segment over. The easiest way to do it, just count. So this one, you gotta be careful when you count, because I guarantee somebody's gonna do this. How far is this from the line? 6, not what? Not 4, because what did they count to? To the y-axis, and you're supposed to be counting to the new line. So it's 6, and then you go from that line and you count over 6. So if this was A, let's say, this is going to be A prime. How far is this one from that line? 10. So over this way we got to go 10, 3, 4, 5, 6, 7, 8, 9, 10. I'm going to run out of space because I didn't think it through very well. If that's B, then this is going to be B. If that's B, this is going to be B prime. And our new segment's going to look something like that. Does that make sense once you look at it? All right, looks exactly the same over here. If we folded it right there on that line, they would match up. What if I wanted to reflect it across the line y equals, let's do y equals 5. It's going to be a horizontal line, good. Go 1, 2, 3, 4, 5. Here's the ones where you got to be careful. Where's A going to end up at? Just explain it to me. Instead of on bottom of the line, it's going to end up on top line. Where's B going to end up at? On bottom. That one's 2. So that's going to be A double prime. That one's up 3, so we want to go down 3. It's going to be B double prime. And our new segment would look something like that. So be able to use those rules. This one, the rules just to count, but you got to be able to draw in either that horizontal or that vertical line, know what you're dealing with. I think we're going to skip that today. All right, this is your assignment. The other thing I want you to do, go back, write 2 or 3, 4 sentences in your notes at the beginning there for reflection. I'm going to come around and check it here in just a minute. So write your
Is that the same one that's on Google?
write your reflection. I hope so.
Okay, so we don't have a new assignment.
I already did that one.
You've already got it done. You're ahead of the game. I think I said that last time, right? If you did it early. You might want to grab some graph paper up there. Go ahead. We got about, what, 7 minutes? Here, about 4 minutes. I'm going to walk